So welcome back, AP Stats students. It's Thursday, May 7th. Today's day 4, I guess, of our AP mock reading week. Yesterday, you guys worked on 2 modified problems that I came up with. I'll talk a little bit more about sort of my logic of how I put those together. So yesterday, you did a lot of work. I didn't do as much work yesterday, perhaps, but I'm gonna go through all my answers today. We'll talk about what units they came from, what major themes or threads they came from. When I talk about my answers, I'll talk about potential common mistakes that we see at the AP reading, those types of things. So that's the goal for today. And then tomorrow, before I forget, my answers today are my typical sort of left-handed, little messy type answers. I'm going to type these up, make them nice and neat. We're going to put them on Statsmatic for you. So if you want to go back and see a much cleaner copy, that will happen. So anyway, let's go ahead and get started. I will just read the problems again real quick. Again, you guys worked on them yesterday. So welcome back to the prep week. I guess today isn't the opportunity to practice. Today is we'll go over the questions. So again, down the bottom here, I just think this is important. Luke and I did our best with the help of some College Board people, some folks, to design questions that we think will be similar in structure and format to what you see on this year's AP Stats exam. We have no idea what's going to be on this year's test more than anyone else. And these are not necessarily intended to be exactly like what your questions will look like, but we hope that they're at least somewhat reasonable in length and type of questions. And I modified a couple existing AP questions. Luke designed his own, and pros and cons to everything. So again, here's some important links. I've had this slide a lot of my presentations for the last couple of weeks, so we'll go through that really quickly. I think I talked about this briefly at the end yesterday. These 5 steps would be awesome if you guys could do all of these. And this link right here, cb.org/AP2020, get ready. These things would be great for you to practice and print out this little slide or whatever. And this exam demo, which came out on Monday, my students did it and found it super helpful. So if you haven't done that, I'll put a little plug in for that I think these things would be extremely helpful to you. So here's the problem. Again, yesterday you saw just what we call the stem, the top part. It was hard to get this in, and I know this is going to be hard to read. In a second, I'm going to go to my document camera, so it'll probably be a little bit easier to read. But if this problem seems familiar, it was what you guys did yesterday. So this was modified from the 2003 exam. When I say modified, I tried to keep the intent of the problem as close as possible. I've changed some wording in the questions and I've added more questions. So I think this problem had maybe parts ABC, maybe A, B, C, D, no more than that. And so I've added at least 2 or 3 components to this. And again, this will be the 25-minute question. So a study was conducted to determine if taking vitamin C reduces the occurrence of the flu. The study was conducted using 808 student volunteers who did not take a flu shot. So that's important. None of them had a flu shot. The subjects were randomly assigned to one of 2 groups, a treatment group who received 1,000 milligrams of vitamin C daily, or to a control group who received a placebo flavored to taste like the vitamin C treatment. So maybe a pill that looked identical, but it was a placebo. All participants were monitored to ensure that they adhered to the assigned treatment on a daily basis throughout the period of the study. So that was important. At the end of the flu season, each subject's medical record was reviewed by a physician to determine whether he or she had contracted the flu during the period of the study. The physician did not know which treatment each subject received, super important. The results of the study are shown in the table below. So classic 2-way table. I'm trying to see if there's some relationship between whether you contracted the flu or didn't, and whether you took vitamin C or the placebo. So is there anything related to potentially the vitamin C helping you not catch the flu or contract the flu? So hopefully a little bit easier to see, a little bit bigger here. So question A, I guess, is this study an experiment or an observational study? Explain your answer. So yes and no answers sort of never work, right? So I think you guys are sort of good with that. So I said, this is an experiment. Sorry. This is an experiment since the health expert imposed treatments of vitamin C and a placebo pill. I didn't know if I was to call that placebo a placebo pill, but and the subjects were randomly assigned to the two treatment groups. So this felt like an experiment to me. That was good. And we typically want part A to be accessible to all students. I'm not going to say that part A is always the easiest. It isn't. But we don't want the toughest one to be part A. So we want students to enter into the problem, build some confidence, and feel like they can earn some points. So part A hopefully felt relatively straightforward. If a student volunteer is selected at random from those students in the study, again, there's a total of 808 students in the study, what is the probability that they contracted the flu? So this feels like sort of a straightforward, I call it basic probability. I don't know if that's the exact term, but it looks like there were 633 people who contracted the flu out of a total of 808. So I said the probability that a randomly selected student contracted the flu is 633 divided by 808 equals 0.783. That fraction is fine. There's nothing wrong with that. Again, this year's exam is designed to be sort of calculator neutral. I think that the term we're using is agnostic. If you have a graphing calculator, feel free to bring it, great. If you don't have a graphing calculator, the test is designed so that you can still take the exam and do well. So I tried to write problems, and I know Luke did the same, so that they weren't sort of heavily calculator active. If you didn't use your calculator much yesterday, that's perfectly okay. It was very easy for me to pull those two numbers off of the table. And so please don't write just that number. It is easy to get those two numbers from the table. That's probably not going to be full credit. Again, I don't know what the scoring guidelines for this year are going to say, but a sentence or something like that is perfectly fine, and we consider that work. So hopefully, again, that wasn't too difficult. Given that a student took vitamin C, so that's kind of the tell here, the clue. Given that's usually a conditional probability. So I was thinking conditional probability. Given that a student took vitamin C, what is the probability that they contracted the flu? So we had a total of 403 students who took vitamin C. Again, I'm not worried about the placebo. I'm worried about just the vitamin C. 302 of them contracted the flu. So my answer here, given that a student took vitamin C, the probability that they contracted the flu is 302 over 403. Again, that number is perfectly fine. There was no reason to convert that to a decimal. If you have a calculator, great. If not, that's okay. Again, we don't like the bald answers. We don't like just those numbers circled. So you can say it in words. You could use statistical nomenclature, whatever you want. Either one would be considered full credit, but just no bald answers. That's going to cost you some points, unfortunately. And sometimes with these probability and from tables, students are able to get the numbers right from the table, and they just want to circle them. But I think Luke and I hopefully have done a good job of kind of driving that point home. Based upon your answers in part B and C, so I'm going to go back and use those two answers. Are contracting the flu and taking vitamin C independent of each other? Again, explain. Yeses and nos are not real good answers. So in this one, I tried to use maybe some more nomenclature as opposed to words, maybe a combination of the two. So I said, if the probability of you getting the flu, given that, that's a vertical line there, given that you took vitamin C, if that's equal to the probability that you got the flu, then those two events are independent. Equal, independent, not equal, not independent. So in part C, we had calculated this conditional probability of 302 over 403. That was actually one of the reasons why I converted it to a decimal. I was trying to compare these two fractions here, and I just wasn't able to do that in my head. So the probability that you contract the flu, given that you took vitamin C, that's the answer we got in part C, so 302 over 403, or 0.749. The probability that you contracted the flu, that's what we calculated in part B, that was 633 over 808. again, looking at those two decimals, those two fractions, I didn't think they were equal, but until I decimalized them, I wasn't sure. So here's where I make my comparison. I said 0.749 is not equal to 0.783. Therefore, contracting the flu and taking vitamin C are not independent of each other. I've graded some problems in the past that somewhat similar to this. And students try and answer it in words. They'll say something like, yes, they're independent because one doesn't impact the other, or no, they're not independent because one impacts the other, or something like that. And we need to see some mathematics. Those answers are not going to get any, hopefully not much credit, if any at all, probably none at all. We really need to see some mathematics here. And again, it said, look at these two answers here. And so we were trying to give you a little hint about going up and looking for those. So part E, and again, I've already expanded the original problem a little bit. Part E, a health expert believes that vitamin C reduces the occurrence of flu in the populations of students who would volunteer for such a study. So perhaps taking vitamin C builds up some immunities in your body and you're less likely to get the flu. State the name of the significance test, I guess state the test that you would use, and the null and alternative hypothesis that the health expert could have used to assess his claim. So the original problem wasn't about inference, and I wanted to get that in there, have multiple themes or threads in this problem. So we need to name the test, and then state the null and alternative hypothesis. So down here at the bottom, I said, well, this was a 2-sample Z-test for difference of proportions. And again, if you had sat through some of my other sessions, I kind of have these 4 or 5 questions that I asked. Does this feel like a hypothesis test or confidence interval? Well, it was a hypothesis test. Do I have 1 or 2 samples? I have 2 samples. Are we dealing with means or proportions? We were dealing with proportions. And I think my last question is, are we going to read a Z table or a T table? And that sort of helps me identify the name of the test. And ultimately go to the calculator if need be and get the numbers. Again, we don't think that's going to happen this year. So we think the inference problems will be maybe name the test, state which conditions. I have that in my second problem. And we might give you the numbers, either the confidence interval or a p-value or something to that effect. And then we want you to make the conclusion. So I said the null hypothesis, p placebo. Again, notice that's not p hat. That's the population parameter. P placebo is equal to P vitamin C. There's no difference, they're the same. The alternative was the proportion of those in the population proportion of those who had the placebo was greater than the proportion of vitamin C, i.e. that's, I think, what the researcher was trying to assess was, did vitamin C help protect you against contracting the flu? That was my null and alternative. Now, what's become super important is that we identify that parameter, those population parameters, in words. So even though I sort of had it in symbols, I guess this is symbols and symbols or abbreviations, that's no longer going to be accepted. So on this year's test, please, and moving forward, always identify that parameter. So I tried to say that in words. P placebo is the proportion of those receiving the placebo from the population of all students who would volunteer for such a study who contract the flu. So again, in previous years, that might have been enough. That's no longer going to get you full credit. P vitamin C is the proportion of those receiving vitamin C from the population of all students who would volunteer for such a study who contract the flu. So just identifying those, I guess those symbols, probably somewhat obvious as to what I was trying to say with my symbols, but you really want to identify that parameter in words, and we would consider that a really good response. So again, part F, assume that the conditions for running this test are met. Okay, I think my next problem, we're going to talk about which conditions we need to look at for a different test. The test resulted in a p-value of 0.0096. So again, this is where In other years, perhaps we would have asked you to get that on your calculator. This year, we understand some students don't have access to their graphing calculator, and we think that's unfair. So we'll give you the number. That's what we think will happen. Based upon this p-value, what conclusions should the health expert make? Explain. So I guess I'm going to interpret those results. And again, my answer here is going to be somewhat generic-y. My first sentence, sorry. My first sentence will be pretty much generic. And if you watch any of my other videos, you'll probably say, yeah, this sounds familiar. This is what Mr. Murphy does. Since our p-value of 0.0095 is less than our assumed significance level, alpha is 0.05, we reject the null hypothesis in favor of the alternative hypothesis. That's a good sentence. I got a lot in there. I state my p-value, I compare it to my alpha level, and I sort of make a decision. What you'll notice, though, there's no context, and I could pretty much use that year after year after year, and I guess I do use it year after year after year. So my second sentence here ties it all together, gets that context in, and I draw my conclusion. The health expert has convincing evidence that taking vitamin C does help to reduce the proportion of students, like the ones in this study, who contract the flu compared to the placebo group. So I know in watching some of Luke's videos, he actually does that in one sentence. His is perhaps a little cleaner or neater than mine. He does it in one sentence. And again, we're not super worried about how you do it, but you need to get all those components in. State your p-value, make a comparison to an alpha level, and then we either reject or we fail to reject. I don't like the word accept, and I think I talked about that in one of my previous videos. I just don't like that word. And then what decision did the researcher make? So those are my solutions. Again, I'm going to type those up, clean those up a little bit. And I actually, at one point, I think it's my other problem, I had crossed out some work, and it's in my other problem. When we get there, I'll talk about that. So I think Luke did something similar, and I thought this was actually kind of a nice little exercise. So I went back through my 6 questions here and tried to find what unit in the CED, course and exam description, that's more teacher lingo. You guys don't really need to worry about that. But the goal was to write a problem that hit multiple units. So question A was from unit 3. I'll call that experimental design. Question B was unit 4, probability. That's probably obvious. Question 4 was, part C was unit 4, probability as well. Part D was unit 4, probability. So right now I have experimental design and probability. Those are 2 of the major 4 themes or threads in the course. And of course, E and F come from unit 6, which is statistical inference. And so in this problem here, I had 1, 2, 3 of the 7 units on this year's test, and 3 of the 4 major themes or threads. That was by design. And the College Board has published that each of your 2 problems will have at least 2 of these major themes or threads. Again, experimental design, probability, statistical inference. So this problem actually had 3, who knows? But each problem will have at least 2, So again, when Luke and I were writing our problems, we talked a lot back and forth, and we decided that, let's try and get as much in there as we can. And we tried to mimic as best we can what you guys will see on the 22nd. So hopefully that helped. That was, again, the longer problem. That was your 25-minute problem. Again, you're actually going to have 30 minutes, and we went through the timer, which was really pretty cool yesterday. That 5 minutes at the end is designed for you to potentially upload your answer. And I don't think I would go too far into that 5-minute time frame. I think I would try and finish up in that 25 minutes, maybe go 30 seconds or something more if you're finishing up, your last question or whatever. But we want to give you 5 minutes to upload your answer. So at that point, once you've uploaded it, that question's gone. You can't go back and work on it. And then after that 30 minutes you'll be able to look at your next problem. So this was from the 2007 exam, free response question number 1. Again, this was modified And I'm going to talk a little bit about that. There's a sort of a nuance here that Luke and I had a really good discussion on, and it goes into the interpretation of the problem and what the question writer had in mind. And so that's the problem when we modify these questions sort of on the fly, and everything was done really quick. Just so you know, each AP discipline has what they call a test development committee. Test development committee meet usually 2 or 3 times a year. And there's about 6 or 8 people on this committee. They're half high school, half college, and they actually write all these problems and design. And it takes a good year and a half typically for a problem to go from, you know, its first thoughts to a final problem. And there's many reviews and many rewrites and many eyes looking at these. Luke and I had each other's eyes and 1 or 2 folks from the College Board, but nowhere near the time that the College Board would. And so there may be some things there that aren't quite as tight as you'll see on your exam on the 22nd. The Test Development Committee, I know, has been working really hard at coming up with this year's modified questions. So the Department of Agriculture at a university was interested in determining whether a preservative was effective in reducing discoloration in frozen strawberries. We all like red strawberries, right? A sample of 50 ripe strawberries was prepared for freezing. Again, I'll come back to this, but if the word random there, I might have felt a little bit better because of one of my questions towards the end, but for now it just says a sample. So somehow we found 50 strawberries and we're gonna freeze them. The sample was randomly divided into 2 groups of 25, so that's good. So we call that random assignment. If the word random was here, we would call that random selection. And so in a perfect world, I would love to randomly select those 50 strawberries and then randomly assign those to the 2 groups of 25. That's not part of the problem. And again, I've modified this problem beyond its original intent and hopefully haven't changed too much. So we randomly assign each of those 50 strawberries to 2 groups of 25. Each strawberry was placed in small plastic bags. 25 bags in the control group were sealed. The preservative was added to the 25 bags containing strawberries in the treatment group, and then those bags were sealed. So I have 50 bags, 50 strawberries, 25 of them are just put in a bag and thrown in a freezer, and 25 of them are treated with the preservative. All bags were stored at 0 degrees Celsius for a period of 6 months. So we put them in the freezer for 6 months. At the end of this time, after the strawberries were thawed, a technician rated each strawberry's discoloration from 1 to 10, with the low score indicating little discolorations. So I guess lower scores here are better. Like, we don't want the strawberries to lose their color. We would love them to maintain their original ripeness, their original color for the 6 months. So in this case, I guess lower is better. Sometimes higher is better. In this case, sort of lower is better. So this problem was written to be what I would define as sort of EDA, exploratory data analysis, sort of the first half of the course. And I've tried to expand a little bit, and there's a little nuance that I'll talk about. Hopefully I can address that well. The dot plots below show the distribution of discoloration rating for the control and treatment groups. So there's my 50 strawberries, 25 in treatment and 25 in the control. I don't think we would ever ask you to type in 50 data points in your calculator. It just takes too much time. And especially this year where we're saying that students don't need a calculator. And so if you see that many data points, don't try and go to your calculator if you have one. Don't try and type them in. It's just not worth it. And that's probably not what the intent of the problem is anyway. Okay, so part A, I added this. This was not part of the original question. The median discoloration value in the control group was equal to 7. I did type all these in. I did do a little math, but I had a little more time. So the median discoloration value in the control group is 7. If a random strawberry is selected from the treatment group, so this group here, what is the probability that the discoloration value is less than 7? And so I counted all the different dots less than 7. And so I said, the probability that a randomly selected strawberry from the treatment group has a discoloration value less than 7 is 19/25. I hope I counted right. That's equal to 0.76. Again, you don't need to convert that to a decimal. That fraction is fine. But don't give us just that. I think you guys are fine with that. Luke and I have probably said that a million times in the last 6 or 7 weeks. So we need to see some language. We need to see some context. We need to see some work, not just that bald answer. Okay, part B and C were the original questions. The standard deviation of ratings for the control group is 2.141. Again, we would never ask you probably to do that on an AP exam. That's just a lot of typing and it's lots of potential mistakes. I did type it in. I did get that number, so that's good. Explain how this value summarizes variability in the control group. So I guess we're sort of defining standard deviation here in words, and it's not easy. That can be hard for some of my students. Again, we think that this year's exam will not be much number crunching, or perhaps a lot less number crunching, much more conceptual and much more explanations. So I said the standard deviation of 2.141 measures a typical distance between the individual discoloration ratings and the mean discoloration rating. So I'm comparing it to the mean for the strawberries in the control group. I like the word typical here and not the word average. Again, we're dividing by n-1. I don't know if you remember that from your standard deviation formula. So it's technically not an average. Typical is, I think, a better word here. So just watch that. Again, that's a nuance, and Luke and I will talk a little bit tomorrow about, how important each word can be. It's actually not an average because my denominator from my standard deviation formula is n-1. So just watch that. My students sometimes can struggle with that. They're good at typing the numbers in. They're good at getting that value. That interpretation is a little bit more difficult. So just watch that. Part C was originally from the problem. So based on the dot plots, comment on the effectiveness of the preservative in lowering the amount of discoloration in strawberries. No calculations are necessary. That was from the original problem in 2007. So we didn't want kids doing any more number crunching back then either. So when I compare these two distributions, it does sort of feel like the whole treatment group is sort of shifted lower. Again, lower numbers here better. So that was good. And so by looking at it really quickly, it looks like, the whole distribution is shifted to the left compared to the control group. Without running any numbers, it does look like the median. Now that would be easy enough to just count the dots, right, to find the 13th little dot here. But you don't need to do that, and I don't have any numbers here. So again, without looking at any numbers, I said the preservative does seem to have been effective in lowering the discoloration in strawberries. Strawberries in the treatment group are centered at a lower value rating, notice no numbers, than those in the control group. The mean and median values in the treatment group also appear to be lower or smaller than that in the control group. So there's no numbers there. I think I've addressed what they asked, and I just got that visually from looking at those two dot plots. Okay, part D and E were sort of modified. E was new. Part D talks about the conditions. This is where it gets a little tricky, and I'll hopefully try and explain that well. Researchers at the university decided to calculate a 95% confidence interval for the difference in mean discoloration between strawberries that were not treated with preservative and those that were treated. Okay, so we're gonna do a confidence interval, and we wanna see, is there a difference between those strawberries that were treated with the preservative versus those that were not? State the conditions and confirm that they have been met for this confidence interval. So in the original problem in 2007, it said, don't worry about the conditions, they've been met. But we really wanted to sort of get that in there. We really wanted to see if you guys, sort of fully understood what conditions need to be checked and whatnot. So Luke and I wanted to get that in there. We wanted to make sure that we're addressing those conditions, how important they are, and what to check. So we need to think about randomness. So the 50 strawberries were randomly assigned to the two groups as stated in the stem of the problem. Okay. Again, way back when I was reading the problem, I would have liked to have seen a random sample of 50 strawberries, so random selection, and then what we call random assignment to the two treatment groups. This problem was not designed to be an inference problem, and I was trying to make it one. And so here's where it gets perhaps a little tricky. We got the random, we're good. We have random assignment, that's all we need, we're good. Okay, is the population greater than 10 times the sample size? If we have a study where we're sampling without replacement from a finite population, then we need to check this. If we have some sort of an experiment where we have volunteers, then we don't need to check that 10% condition. So without knowing the exact intent of what the question writer was trying to do way back in 2007, I was assuming, this is sort of where the leap of faith comes in. I was assuming that we were sampling from a finite population from a strawberry farm, and that we needed to make sure that the population was much greater than 10 times the sample size. So I said, it is reasonable to assume that there are more than 50 times 10 or 500 ripe strawberries, perhaps similar to the ones in our study, in this population. And here you'll see, I said population farm. I don't really know what that population meant. And that's where, perhaps when I wrote the problem, I got into a little bit of trouble here, not really fully understanding the exact intent of the problem. So again, if we're sampling without replacement from a finite population, then we definitely need to check this. We need to see the numbers. This here is an assumption. I have no idea how many strawberries are in a strawberry farm, but I assume it's over 500, and that's probably okay. If we have volunteers or something like that in an experiment, then we don't need to check that. So Luke and I had a good discussion today about this. And again, we're not sure exactly what the intent of the problem was, but we want to at least talk about that and hopefully kind of clarify that for you. So hopefully that helps of whether you need to check that condition. Then I needed to see if my two sample size were big enough. So the shape of my sampling distributions were at least approximately normal. I'll go back and look at the picture in a second. I kind of keep this n is greater than 30, or both my sample size greater than 30. Again, this problem, we weren't originally designed or asked to check conditions. And so my gut says if we were, they probably would have had 35 strawberries in each group or something like that. But I wanted to get that in here and just get you guys thinking about, which conditions do we need to look at. So I said we don't quite meet this rule of thumb number, and that's all this is. This 30 is not a magic number. 29 probably fine. Sometimes 31 not enough. So this is just a rule of thumb, and we want you to understand that. I'll go back and look at the pictures in just a second. You can see I crossed out some words here. And at one point I was going to go back and pretty up my answer here. And then I decided, no, actually, if you're choosing to write your answers out on this year's modified exam, that's perfectly fine. Don't waste any time erasing, just cross it out. Readers are used to following students' work even when it's crossed out. So I did that sort of on purpose, I guess. So we don't quite meet this n is greater than 30 rule of thumb number, but there is no strong skewness in either sample distribution. Both distributions, and I added that word when I checked my answer, I said both look. Nope, I wanted both distributions look at least approximately normal. And it appears that there are no outliers in either distribution. You can see I sort of did this on purpose. So this condition is met. So I guess we've met the conditions to run the test. If we go back here and look at our two original dot plots, I guess that's at least approximately normally distributed. And I guess that one's at least approximately normally distributed. I don't see any strong skewness in either one. I don't see any outliers, although I didn't run all the numbers. And so again, trying to make an EDA problem, exploratory data analysis, inference, I perhaps took some liberty into what the original question writers wanted. So I hope I did a good job with this population greater than 10 times the sample size. Okay, part E, and again, this is the 15-minute problem, so probably A, B, C, D, E. That's our best guess. We probably have five parts to this problem, but again, that's just our best guess. The confidence interval the researchers obtained was 0.16 to 2.72. To sample, I'm looking for zero. Is zero in there, but we'll get back to that. Based upon this confidence interval, comment on whether there would be a difference in the population mean discoloration ratings for the treated and untreated strawberries. On two sample confidence intervals, I guess I'm looking for zero. Is zero contained in that interval? And it doesn't really matter where zero is. It doesn't have to be right in the center of the interval. It can pretty much be anywhere. So I said, since zero is not contained in the 95% confidence interval for the difference in means, we can conclude that there is a significant difference between the mean ratings for the two groups at the alpha equals 0.05 level. And again, zero is not in there. We think there is a difference between the two groups. We think there would be a difference in population mean discoloration ratings for the treated and untreated strawberries. That's the context, right? The population mean discoloration rating for the untreated strawberries is estimated to be between 0.160 and 2.72 units. I was looking for some unit. I don't know what a discoloration unit means, but that's what we were told. So we feel that those in the control group are higher than the population mean discoloration ratings for the treated strawberries. Again, going back to this picture, that's what we thought. It does appear that the preservative is helping the strawberries keep their color ratings after being frozen for 6 months. So I took an EDA and tried to make it an EDA and inference, and I did not have the benefit of having all those wonderful people on the test development committee sort of helping me out. So hopefully Luke and I did a good job coming up with some problems, a reasonably quick turnaround, and we're hoping that this gives you a better idea of what to expect on this year's exam. So again, I went back to each of these questions here and tried to come up with, okay, part A I said came from unit 1. Again, don't worry about the unit number as much as which major theme or thread. And unit 1 was what I call exploratory data analysis. Question 2, standard deviation, that was also unit 1. That was exploratory data analysis. Part C, unit 1, exploratory data analysis. So that's really what the problem was, the intent of the problem originally. Again, part A was mine, part B and C were original, and part D and E were sort of combined on the original problem where there were no, you didn't have to talk about which conditions, checking the conditions. So part D and E are from unit 7, and those are what we call statistical inference. So I guess I had EDA, statistical inference. And again, this problem met, oh, excuse me, this first one is probability. Sorry, first one is probability. So again, I tried to get 3 different themes or threads. So probability, exploratory data analysis, inference, and inference. And again, we're told that each question will have at least 2 of the 4 major themes or threads. I tried to get at least 3 in each one, and I think Luke did something similar. So those were my answers. Again, I'm gonna type those up and clean those up a little bit. I took 2 problems and tried to make them a little bit longer, perhaps add a couple of different components to them. And expand on what this year's problems, which will be a little bit longer. So I think I have enough time to just put this out here. This is on the College Board's website. So if you're choosing to type your answers in, which is perfectly fine this year, the College Board came up with what they're calling keyboarding tip sheet for this year's exam. So how do you type in mu? Well, you could type in mu. How do you type in X bar? You could just do X dash bar. So this goes through how we would want you to type in some of your answers using perhaps statistical nomenclature or statistical symbols, something like that. If you're one of those who think you're going to be typing in your answers, on your desktop, on your computer, on your phone, whatever, I think this would be well worth your time to go look at again, what we're calling the keyboarding tip sheet for this year's modified exam. You know, my students are saying, you know, Mr. Murphy, how do I type in p hat? You know, you can just type in p hat or something like that. So p hat, that's perfectly fine, because you may not have that little caret symbol. So those were my answers. I hope that helped. Again, I'm going to clean those up. We're going to put that on StatsMedic. So if you want to go back and look at these, or you know, your teacher wants these or whatever, that's going to be perfectly fine. Again, real quick, you have sort of 3 options as to how you can submit your answers this year. I know Luke went through these in some great detail. So option 1, option 2, option 3. Well worth reading these, I think, and well worth trying to come up with what, long before the 22nd, how you're going to answer those. I can't answer that for my students. They keep asking me, Mr. Murphy, what do you recommend? I don't think I have a good answer for that. I would recommend whatever you think you're the most comfortable with. If you're good typing in, that's going to be perfectly fine. If you like to write like I do and whatnot, that's perfectly fine too. So I would think about that ahead of time, and I would also do that AP demo. I think that would be super helpful. This talks about a little bit as to how to submit, how you actually upload your answers. And again, this is well worth reading and thinking about and practicing on the AP demo site long before test day. So 25-minute question, 5-minute uploading, 15-minute question, 5-minute uploading. You hopefully don't need that full 5 minutes, but I think I would give yourself those 5 minutes. So that's pretty much it for today. Those are my 2 solutions. Hopefully that helped, and hopefully you guys were able to answer those yesterday. Tomorrow, hopefully kind of a fun day. Luke and I, you know, sort of bittersweet. We had a good discussion today. We put together our PowerPoint for tomorrow. We've had a ton of fun, a lot of work, but a lot of fun putting this together. He and I have worked together before, and we knew each other, and that made it perhaps a little easier to, we're going to come up with some final tips, you know, last minute tips, last minute best wishes and good luck and all those things. So we'll see you tomorrow, same time. We'll talk about lessons learned, you know, things that perhaps we could have done better. We've gotten lots of great emails directly from some of your teachers and from students and whatnot, and we appreciate that. We hope that we've helped. So please be safe. Please tune in tomorrow. We'll do some final last minute, you know, tips for doing well on the AP exam. You know what I'm going to say, right? In context, show your work, right? All those things that we've been talking about the last 6 or 7 weeks. So be safe. Take care of yourself. Take care of your families. Thanks for tuning in today. We'll see you tomorrow at 2 o'clock, and hopefully kind of a fun day. And we're going to sort of tie everything together and wrap it up. So have a great afternoon, and we'll see you tomorrow. Thanks.